So here's a video about section 5.1. We're going to skip up to that section and talk about quadratic functions. In quadratic functions, we're going to talk about the characteristics of parabolas and what the graph looks like and how to solve problems involving the quadratic's maximums and minimums and try and find some of the characteristics of those polynomials. So first of all, a quadratic function always has a parabola shape, and we're going to look for, it's going to have an axis of symmetry down based on the bottom point, or if it's upside down at the top. This is sometimes called the vertex, and we'll talk about how to find that. We're also going to be interested in where it crosses the x-axis, the x-intercepts, and a lot of things will be based on this axis of symmetry through the vertex. So if you know that the point here, -3, 1 unit to the left of the vertex has a y value of -3, then 1 unit to the right of the vertex will also have a unit of y value of -3. So there's a lot of symmetries involved, and we'll talk about these. And so those ideas, here's a picture they have in the textbook. Based on this, when you throw a basketball, ignoring air resistance, it follows a parabola. So is this shot going to go in the basket? And I think what they want you to do is, if this is the vertex, then that's kind of an axis of symmetry. And so 1, 2, 3, 3.5 to the right, or to the left, 1, 2, 3, 3.5 to the right is going to be this height. So the ball over here is going to be that height, so you're going to miss it. I think that's the idea that they want you to use from this picture. You can look at the symmetry, and you can look at the axis of symmetry around the vertex of the parabola and get some information. So here's the formal idea that they have in the book. There are two forms that we're going to talk about, at least, and maybe a third one in a little bit. The general form of a quadratic function is f of x equals ax squared plus bx plus c, where a, b, and c are real numbers, and if a is 0, then the x squared term goes away, and you just got a linear function, bx plus c. So for quadratics, the a has to be non-zero. And then you can also talk about what they call the standard form, which is if you've manipulated the equation, the formula for the equation, into this form, ax minus h squared plus k. And in that case, this is going to be shift h to the right, h to the right. Well, let's shift by h. I don't want to say right or left because I don't know if h is positive or negative, so I'll just say that. And left, right, and shift by k, up and down, up and down. And so the idea is, if you've got a nice, you've got a quadratic function written in the standard form, it's easy to see where the corner of it, the vertex of it is. It starts at the origin, but it's been shifted h left and right and k up and down. So you can get a quick drawing of the parabola based on the standard form. And we're going to show you some of the algebra to connect the a and b to h. Turns out that h is always equal to negative b over 2a. And then k is equal to the height at that point. So plug h into the function, and you find the height at the vertex. Y value of the vertex. So we're going to work with a couple examples where you can use those two forms of the equation. So suppose you have some equation like this. Here's g of x. It's not written in general form. So the general form, you write it as g of x. You always write the x squared term first, so that's equals x squared minus 6x plus 13. So from that, in that little equation, we can get that h equals negative b over 2a, which in our case is negative 6 over 2 times 1, which is 6 over 2, which is 3. And if you plug in 3 into the formula, you get the height, but just quickly you can see that the base of this parabola is or the vertex of this parabola is at x equals 3, and that's where the axis of symmetry is, and k is going to be g of 3, which is 3 squared minus 6 times 3 plus 13, which ends up being 4, right? So 1, 2, 3, 4. And so you can draw a parabola. Generally, it's going to be that shape from that form. And if you know h and k, you can also write it in the standard form, g of x is 1, because there is a 1 in front of the x squared, x minus 3 squared plus 4. So once you know how it's been shifted, you can write it in the standard form. You might have also heard about how to find the standard form by completing the square. To find the standard form. But we're not going to really focus on that in this course, but it is if you know that technique, it can be simpler than plugging in h and k to find this. So in this case, g of x would be, you do the x squared minus 6x, take half of 6 and square it, and you get 9. And we had the plus 13. Since we added that 9, we have to subtract the 9. And x minus 6x, x squared minus 6x plus 9, you've set that up by plugging in that 9 so that it becomes x minus 3 squared. And then 13 minus 9 leaves you with a plus 4 at the end. So if you know that technique, great, you can use it. I'm not going to require it or test it. If you know the formula for h and k, you can use those to do this as well. But if you know how to complete this. So I wanted to show you an example of where quadratic functions come up naturally, and how to use those ideas of the symmetry and the vertex to solve certain problems. So let's say we want to know. So if the price of something goes up, the demand for that item will usually decrease. That's just a kind of general rule. And so what we can do is draw a little graph for the price and the number sold, the demand. And in our case, we say if it's at 84,000 subscribers with a charge of $30, it would be at 84,000. And market research suggests that if the owners raise the price to $32, they would lose 5,000 subscribers. 32, it would go down to 79,000. And then what they say is, if you assume that the subscriptions are linearly related, what price? Now we're going to switch. What price? Here's the question that they're asking: what price do you set to maximize their revenue? So this function for the demand is going to be a linear decrease, and we can find a formula for that. So the demand equals 84,000 minus the slope, or plus the slope, but the slope is negative, x minus 30 is the point slope formula. What is the slope from here to here? Well, whoops, what happened there? The rise is negative 5,000 over the run, which is 2. So the rise is negative 2,500. So my demand is 8,400 minus 2,500 x minus 30. So there's my formula. If I set the price at X dollars, I'm gonna be able to sell this many newspapers. But what did they ask me for? They asked me to maximize the revenue. So how do I find the revenue? How much money am I gonna make? What's the revenue? Well, it's the number sold times the price per paper. And we set the price to be X, and the number sold is this here what we have, 8,400 minus 2,500 x minus 30 times X. X is the price. So if we simplify that a little bit, we've got 8,400 minus 2,500x plus 30 times 2,500 is 75,000 times x. So we can make that a little bit nicer and get 8,400 plus 75 is 83,400 x minus 2,500 x squared. So there is where we have our quadratic formula for revenue. And if we write that in the standard form, revenue is minus 2,500 x squared plus 83,400 x. Once we get it in that form, what were we asking? We were wanting to know what the maximum value of this is going to be. And what happens is, let me give myself a little more space here. What happens is this parabola is going to be a nice parabola here, where what's the plus c here? Plus c is 0. And so what's the y-intercept? 0, which means if I set the price at 0, I'm going to sell lots of these newspapers, but my revenue is going to be $0 per newspaper times a lot. It's still $0. Revenue. And if this is X dollars for price, as I sell more, my revenue is going to increase, but at some point, when I raise the price, my revenue increases. But if I raise the price too much, eventually I'm not going to sell any more. No more sales. So my maximum is going to be here. And so it's a parabola, and we're looking for the vertex of that, and the vertex is at negative b over 2a, which in our case is negative 83,400 over 2 times negative 2,500, which is 83,400 over 5,000, which is 16.68. So if I set the price at $16.68, that will have the maximum revenue. And so it's easy to find the x value where you have a maximum revenue once you can figure out this formula. Then I would have to calculate the revenue by plugging 16.68 into my formula. The last thing we're going to do with parabolas, the most common question you're going to need to find or solve about a parabola is when is it equal to 0. So most of the time, in most problems, you want to either know the maximum revenue or the minimum minimum cost or something. So you want to find a maximum or minimum for a parabola, and that's at the vertex. The other thing you might want to know are the intercepts. So the y-intercept is usually easy. You just plug in x equals 0. It's the constant term. The harder one is the x-intercept, where you have to solve f of x equals 0. And it turns out that sometimes there's no solutions. If the plus c is large enough that the whole graph has been shifted up and it's above the x-axis, there's no solutions. If it turns out that the parabola just barely touches the x-axis, there could be just one solution. If the vertex is below in an upward opening parabola, then there's going to be two x-intercepts, and they're always going to be symmetric around the axis. So if one is 1 unit to the left, the other will be 1 unit to the right, for instance. So how do you solve these? Well, you have to set the function equal to 0 and factor. So let's do f of x equals x squared minus 5x plus 6, for instance. Then you can, if you can factor that, x and x, the last times the last should give you 6, and the inside terms should be add up to minus 5, so that would give you minus 3 and minus 2. So x equals 3 or x equals 2. And that tells us that the vertex is between those, halfway between 2 and 3, which is 2.5. And if you check our little formula, h equals negative b over 2a, what does that come out to in our case with this equation? Negative b is negative 5. 2a is 2 times 1. And lo and behold, that comes out to be 2.5. So our little formula finds a value that is symmetrically between our two x-intercepts, 2 and 3. So if we were to graph this, let me try that here, we could get a pretty good rough estimate of what this parabola looks like just based on that information. We know 1, 2, 3, 4, 5, 6. We know it crosses here and here. We also know its y-intercept. The y-intercept is 6 because when x equals 0, set x equal to 0, and we get 1, 2, 3, 4, 5, 6. And the axis of symmetry is right in between 2 and 3. So that's at 2.5. So this value over here is 2.5 to the left. And so 1, 2, 3, 2.5 to the right, we're going to be at the same height. And the vertex is going to be on that axis and in a kind of parabola-ish way that I can never get them to line up when I try and draw. You can get a decent graph of the parabola just based on very little calculations once you've factored this. Or if you can't factor it, you can also use the quadratic formula, which to solve when f of x equals 0, you get x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And I might do a little video explaining where that comes from, but if you've seen that before, great. If you haven't, we'll be mostly trying to factor. But I did want to point out quickly that this is one example where this minus b over 2a comes from. What we get is minus b over 2a is the center, is the vertex. And then we get one solution, which is minus b over 2a plus square root of b squared minus 4ac all over 2a. And the other one is minus b over 2a minus square root of b squared minus 4ac all over 2a. So we get those 3 points. We get the vertex in the middle, and to one side, which is square root of b squared minus 4ac all over 2a to the right, we get 1, 0, and square root of b squared minus 4ac over 2a to the left, we get the other 0. Now, if that square root ends up being a square root of a negative, those are imaginary, and so those don't have a real answer, so we don't get any real zeros, and so that's the example that we had up here where we would have no solutions. So there's a lot of ideas floating around there that we'll talk about on. So here's one more example we will talk about. A rock is thrown upward from the top of a 112 foot high cliff, and it's thrown upward at a speed of 96 feet per second, which is really fast, but they pick that number so that it'll factor nicely, but it's really fast. You should think about how fast that is in miles per hour if you can figure that out. And so in that case, we get this equation for the height of the ball. The minus 16 t squared comes from the force of gravity, being 32 feet per second. For calculus reasons, we have to divide that by 2 to get the coefficient here, 16. This 96 feet per second comes from the feet per second, and the y-intercept of 112 just goes out at the edge. So what we've got, let's do a little picture here. Here's the cliff, and here's well, let's not make that high. Here's the 112 foot high cliff, and when you throw it, it goes up and then it lands. It's going to be a parabola like that. And here's the vertex, and here's the x-intercepts, and here's the other x-intercept, but that one we'll ignore because obviously when time is negative, and that's probably not the answer we're actually looking for. And this is seconds. And so you can ask these three obvious questions, and they have easy answers based on what we've done before. When does the rock reach maximum height? Max height when at h equals negative b over 2a. So that's the height, that's the when, that's the x value of the vertex. So negative b over 2a is negative 96 over over 2 times negative 16, which is 96 over 32, which is 3. So we know that this hits a maximum 3 seconds after you threw it. How high was it? What was the maximum height? So this is actually the time at the maximum height. And then the y value at the maximum height you plug in 3. H of 3 is negative 16, 3 squared, plus 96 times 3, plus 112. And you get an answer. What's the last thing that you can do? The last question they ask is, when does the rock hit the ocean? The last question is, find the x-intercept. So the last question is, find the x-intercept. H of t equals negative 16 t squared plus 96t plus 112 equals 0. You want to know when the height ends up being 0. And so how do you solve that? You need to factor or use the quadratic equation. But before you jump right in, if you can factor out some nice term out of these things, you've got large numbers or not very nice numbers, see if you can factor out something. So if you want to solve this, you can factor out the 16, negative 16, and you're left with t squared minus 6 times 16 is 96, and 7 times 16 is 112. Oh, whoops, so that's 7. And so then, if you're able to factor that, you want the t and the t, and this is going to have to be minus 7 and plus 1, so that then when you FOIL that, you have t squared plus t minus 7t, which gives you the minus 6t in the middle, and the minus 1 times minus 7 gives you the minus 7 that you want. So then that says that the h equals 0 when t equals negative 1 or t equals 7. And only that's the good answer. T equals negative 1 doesn't make sense for our case because that would be before you threw it. So this value here is the x equals 7. And the x equals minus 1, it is symmetric. So that's 4 seconds after it reached the top, and that would be 4 seconds before it hit reached the top. But in practical terms, that was before you threw it, so it doesn't count. But it still maintains that symmetry. So what we're looking for in these problems is, given the formula, or maybe even come up with the formula, but once you have the formula, the main things that you're going to try and need to solve for about a parabola are the y-intercept, the vertex, which is the h equals minus b over 2a, and when it crosses the x-axis, when it's equal to 0, when it lands, or when the profit becomes 0, or something about 0. And so you can do that by factoring. And if you can't factor, you can use the quadratic formula.